Hi, everyone. Thank you so much for joining our webinar today on Vehicle Spy's new post-analysis feature, DataSpy. We really appreciate your attendance and continued support for our company. Our host today is John Mitchell. He is the Senior Director of Business Development here at Intrepid. If anyone has any questions throughout the presentation, feel free to use the Q&A feature or the chat, and we'll try to answer as many of them as we can before we finish. This webinar is being recorded, and we'll be posting the video on our socials as well as sharing the presentation slides. So make sure that you're following Intrepid on all of our accounts so you can access those resources. Thank you all again, and without further ado, here is John.
Thank you, Jordan, and thanks everyone for attending. Intrepid's not a huge company. We wear a lot of different hats, and one of the hats I wear is I'm the product manager for our data analysis tool that we call DataSpy. And we decided to include this tool in vSpy recently. And so I'm going to be giving an overview of the different versions of DataSpy. It's been a product for quite a while, and there's a number of different versions, some that run on our cloud-based data logger interface and some that can just run on your PC. So I'll give you an overview of that, talk a little bit about the different versions of DataSpy, and then the basic plotting features that you can use to plot MDF files, SQLiteDB, or VSB plus VSDB files. If you're familiar with our tools, the VSB is the raw message data, and the VSDB is the decoding file. You can also open log CSV files with DataSpy as well. And I'm going to show you some of the key features of DataSpy. You can search for complex events across thousands of files, analyze multiple files at the same time using this auto open consecutive files feature. Showing you how you can correlate vehicle network data with GPS mapping data, and analyze individual frames for multiple cameras, time aligned with vehicle network data, so you can see exactly what's going on in the cameras with time aligned with what's happening on the network. And then also showing you some of the cloud-based features of DataSpy. And I'm going to be switching back and forth between the PowerPoint and live demo here, because I think the live demo is more interesting. So this slide shows you the many different versions of DataSpy. The new one is DataSpy vSpy that we've just decided to include with vSpy, starting in the launch of vSpy version 3.9.17. This version of vSpy is not released yet. We have betas that are based on 3.9.16, which have the feature added, and we can get you a beta of it. But the first time it'll be available in an official release is in 3.9.17. And like I said earlier, it's a tool you could use to analyze MDF files, SQLite, or log CSV files. There's no license requirement to use this version of DataSpy that's included with vSpy. However, you can't launch it by double-clicking on an exe. You can only launch it through an icon within vSpy, so you have to be running vSpy in order to use it. And it also there's one feature that you can use on the PC version of DataSpy that you don't have with the free version that's included with DataSpy, and that is we have this data mining library we call IPA, and that library is still only included if you have the PC version of DataSpy. But all the other features are included in the version that's included with vSpy, and it's included in all versions of vSpy, regardless of whether they're basic or pro or enterprise, at no extra cost. And the other two versions of DataSpy are DataSpy neoVI, which is the version that runs on our cloud-based data logging system we call wireless neoVI. It's well integrated with wireless neoVI, allowing you to click on links in wireless neoVI and open files directly from the cloud without having to download them. And I'll give a brief review of how DataSpy works on the neoVI server. It's really one of the use cases that shows the biggest benefit of DataSpy, because it's a web-based application. it's designed to run on a browser window. And in these versions that run in vSpy or on the PC, it uses embedded Chrome to allow you to run them on, within a PC application. But the program itself was designed to run on the cloud. And these cloud-based versions, they're not free. The license is based on a number of seats that you buy, that simultaneous seats. So you could buy 10 seats and then 10 people can use it at the same time, which is actually probably 100 users could use 10 seats, because just we found that most people aren't looking at data all day long. And so anyways, but yeah, so there's the Wi-Fi version, and then you can also run the cloud-based version on a server without having wireless neoVI. So you could have a server where you have a lake of a bunch of MDF files and you want to use the cloud-based features of DataSpy. We can deploy it on that server, and you can use the cloud-based features without having wireless neoVI. So just some of the reasons why we decided to include DataSpy with vSpy. We haven't had huge amount of sales for DataSpy PC. It's kind of the discoverability is tricky, with that. Most of our sales of DataSpy have been through the cloud-based applications of it, which, as I said before, are some of the biggest, most beneficial features are in the cloud version. And but I've done a lot of data analysis throughout my career. I spent about 25 years doing engine calibration and transmission controls with OEMs in the US, and I've used a lot of different data analysis tools, and we packaged in a lot of the best features of the tools that I've seen. We've kind of packaged them in and simplified them in DataSpy. So it's got a lot of knowledge built into it for making data analysis more efficient. And so yeah, DataSpy, the reason we originally designed it was to work with the cloud-based, Wi-Fi tool. And our existing data analysis program that's built into vSpy is not a cloud-based application, so you couldn't have it run on the cloud without a complete rewrite. So that's really why we started it originally. But we've put a lot more effort into it, and it's a lot more feature rich than data analysis in vSpy. So that's why one of the reasons why we wanted to include it in vSpy. And we're hoping to increase the exposure of this powerful tool, so to encourage customers to buy licenses for DataSpy Wi-Fi and DataSpy Web. And also we want to improve our customers' PC data analysis capabilities. And we're trying to integrate it really well with vSpy so that you can get from your network data into analyzing signals more quickly. So if you have any questions, you can ask them in the chat. Periodically, I'll check the chat to see if there's any notes in there, and I'll see if there's any questions, especially if the questions are in the context of what I'm talking about. I'd be glad to answer them. Okay, so this is how you launch DataSpy from Vehicle Spy. If you have your messages buffer full of decoded messages, like I have shown here in this screenshot, you can just click on this icon that shows DataSpy, and it will create an MF4, which is the ASAM standard MDF file format. It'll make an MDF4 file, and then it will launch DataSpy and open that file in DataSpy, and you can start analyzing signals with it. And once it does launch DataSpy, you can use it just like you would the PC version of DataSpy. You can open up different files, so it's, the reason we only allow you to launch it from vSpy is we didn't want some customer to strip the exe and then, try to market it as a standalone tool without having any affiliation with Intrepid control systems. So most of my live demos today are going to be just with the PC version of DataSpy, but all the features are supported in this, the same way. And I will do a demo to show, how to open up, how it works, right in vSpy. And we're also working on integrating DataSpy into vSpy so you could use it for real-time analysis to replace the signal plot. That hopefully we'll have something ready there by probably first quarter of next year, would be my guess. This slide shows the link to the installer for DataSpy, the PC version of DataSpy. And if you're so inclined, you could go to this site and download it. And there's the zip file that's there when you download it has a password, and the password to unzip it is data_spy-plot. And when you install it on a new laptop or a new PC, you get a free trial license for a week. So if you wanted to play around with it right now, you could do that and download it, and you can use it for a week, because I know the official release of vSpy is not going to be out for a little while. And you know, some of you may have the beta, but I'm not sure. Okay, so now I'm going to go just to the PC version of DataSpy, and I'm going to open a data file. So you go to the File menu, open Data File, and then click on a file. And these files that I have open here are SQLiteDB format, which is the native format that our files on our cloud server are stored in. And we use that format as our native format because it's more post-processor friendly than the MDF format, and we use it to make MDF files, and we use it to make MAT files and other things. But anyway, so when you open a file, it lists all the signals here in the channels window, and there's 4 columns shown here, and you've got the signal name, the comment, the units, and the number of records there are for each signal in the file. And for the comment, if it's a file that's created with our tools, the comment is a combination of the message name and the network name, separated by this little vertical bar. And this particular file is a fabricated file so that we could share, you know, with these demos, because, you know, we don't share our customers' data with, you know, with the general public. So this file is fabricated for that purpose. So you could click on any one of these headers here, and it'll sort the signals by whatever header you choose. So if I click on the units, I'll sort by units. And then here, for example, I could pick 3 signals: engine speed, turbine speed, and output speed. And they all have the units of RPM. And I can click and drag those signals onto the plot area. And if I drop them here, they'll plot them all on a new common y-axis. And if I plot them further in there, it'll create a unique axis for each signal. And so since these signals are all the same units, I'm just going to drop them on the same common axis. And by default, it scales the time axis and the y-axis to span the whole file. So like the x-axis in this plot is the time axis. And you can right click and you can add more YT graphs, and these YT graphs all share the same common time axis. And so then you can grab some torque signals. For example, here's a bunch of torque signals. I can drag and drop those onto the middle plot, and then we'll put accel pedal and brake pedal on this the top plot. And you can also hide the different windows, like the channels window. You can press the Shift C and it will hide the channels window, and the Shift O will hide the output window. So you can really fill in the screen with plotted data. And because I know if you're trying to analyze a complicated problem in your data, it helps a lot to be able to fit a lot of different signals on the same screen. So we really designed DataSpy to allow you to do that. And so most of the features are, you know, for DataSpy are shown in these toolbars, the toolbar across the top. And I'll turn the channels list back on here. Yeah, most of the features are shown in this toolbar across the top. And so the first toolbar, and if you hover your mouse over the buttons, the first tool button gives you a floating description of what the button does. So this one is for creating a subset. So you click on this, and it'll allow you to create a subset MDF or CSV file from the data that is shown that you currently have open. And so by default, it checks the signals that you have plotted. So if you want to create a subset for the signals that you've plotted to share with a colleague, you can just click on that icon and then save the data. And there's different ways of describing the time range to save. There's the default is the beginning of the view to the end of the view, but you can also save the data between the cursors, cursor 1 and cursor 2, or the beginning of the file to the end of the file. So you can choose, how you want to define the start and end of each file, and then hit save, and it'll ask you for a path to save the file to. And then so this other button here, the next button is to show these tick marks, measurement points on the y-axis. So if you wanted to put a frame of reference at a certain value, it creates these cursors. Some tools have this. I don't really like it myself. I don't usually use it. I tend to use the features I like because I'm my role is defining the priorities of all the features, and also testing, making sure that they work in a logical way. But some people like to put a line on a graph that corresponds to a certain value in the axis. And oh, by the way, I'll show also, I can plot some more signals here on this top graph. And sure. Not sure why it's looks like it's in kind of some weird state for some reason. Yeah, I noticed that the header of the toolbar was like in pink for some reason. I don't know why it was doing that. So I'm just gonna start over here. Yeah, so just getting back to where I was. It might have had something to do with my hiding the windows or something. So yeah, I wanted to add a few of these signals to this graph up top. And in the right-click menu, you can show all visible channels y-axes. So if you turn that on, so on this top graph, I have these two signals, brake pedal and accel pedal. They both share a common y-axis, which is this one right here on the left. And these other three signals have their own y-axis. And so if you have a lot of signals on the same graph, it can be helpful to see, the axis for every one of them. But it takes up a lot of space if you do that. So typically I like to turn that off, and then it only shows you the axis for the signal that you have selected. So you could click on a signal in the window, and it'll show that one, in the on the side of the graph there. So anyways, yeah. So then this button will initialize the cursors in the current view, the value cursor. So if I click on this, it puts the two cursors in the current view. And also any tool buttons that have a hotkey, assigned to them, have the hotkey shown with the in parentheses at the end of the floating text. So in this case, it has the I shown at the end. So the small case letter I is the hotkey to bring the cursors into the current view. So so there's these two cursors, and then over here in the legend, it shows you the a number of parameters about there's the value at cursor 1, value at cursor 2, the delta value between the cursors, and it has a bunch of other statistics like the min value, the max value, the mean value. These are all based on the data that's between the cursors. And you can zoom in to the plot window, and you can, if you hold down the number 1 key on your keyboard and you click on the screen, it'll move cursor 1 to wherever you click. And if you hold on cursor 2, then it will move cursor 2 to wherever you click on the screen. And so it allows you to really, easily zoom in on something of interest here. And then, this third button zooms the time axis into the data where the cursor is. So, and then also there's a hotkey number 3 for that as well. So if you hit number 3, it'll zoom the x-axis into, where the cursors were. And there's a lot of different ways of adjusting the time axis in the window here. The one I use most frequently is I just use the mouse scroll wheel. If you hold your mouse in the plot area and you zoom out with the mouse, that will zoom out in time. And it doesn't matter where you are. If you swipe the scroll bar when you're in the plot area, it'll zoom in or out of the time. And the same thing with the y-axis. If you can click and drag on the time axis, I'm sorry, the y-axis, and then if you want to zoom in or out, you can just use the mouse scroll wheel. It's usually pretty convenient. But just like the y-axis, you can click and drag the time axis to adjust the time axis. And you can hold the shift key down and hit the the right arrow and left arrow, and you can scroll in time. Also up here at the top, there's these 2 text boxes. The first one is the start time. It has the letter S next to it, and then the W is the width. So if you put a 0, and this is in seconds, so that's the start time. You can set it to 0 in seconds by putting a 0. And then you can set the width by putting the width of the window in this box here. So this is 200 seconds. So so if you look down at the time axis now, you can see that there's 200 seconds worth of data shown here. And sometimes you want to keep the window width a certain distance, so you can do that. And there's several other buttons here for zooming in, X, and so here you can zoom by clicking on a rectangle on the screen. So right here, for example, there's this area right here is kind of dynamic, so I can click and drag on that, and then it'll zoom the y-axis for where I drag my rectangle to the area that I dragged on. And for all the other plots, it'll zoom the time axis to fit it. So if you wanted to see something of interest, you could really zoom in on something quickly, using that feature. And there's other buttons to click and zoom, incrementally in, zoom out or in on the x-axis. I never use them really because it's maybe too many ways of adjusting the time. And likewise, there's buttons to click on the Y, but I always just use the this window here. Also, there's a gear icon that is the overall setup of DataSpy. So it shows you all the graphing objects you have on the screen, and you can have multiple pages of setup as well. So in this case, I only have one page, but you could have a page for transmission parameters, a page for fuel control, a page for torque management. So you could have all these pages, and the time axis is synchronized among all your pages. So you could be analyzing some data on your torque management page, and then realize there's an issue with the transmission, and then you can switch over to the trans page. But anyways, and it shows, you can pick the page, and then it shows you all the graphs that are on the page. So in this case, I have 3 plots. So it shows you the 3 plots, and it has all the channels that are plotted. And you can change the color of the channel by just clicking on the channel and clicking on this color and pick whatever color you want. You can define, there's like a list of default colors that it chooses automatically. So you could pick, I know different people see colors differently. So you can define the default colors so that they're colors that have a good contrast. I'll try to do that in a second. And it also supports the black background. I know a lot of people like the black background. I got used to the white background for printing. It's not just kind of what I like. So, but yeah, this is the overall setup. And if you right click on any parameters here, and you can click on configure channel, and it takes you to that same UI to see overall how are you set up there. You can also, I guess I'll check to see. Oh, here's a chat with a few questions here. Yeah, I see the question about 3.9, 14, 15. Yeah, it actually is included in 3.9, 14, 15, but there's like some issue with it, which is why I didn't mention it. So we'll keep track of, we'll send an installer, a beta for DataSpy 3.9.16 that has it fully functional to everybody who's attended this meeting today. And then you can use it. So yeah, 3.9.16 was supposed to be released earlier, so that's why we kind of thought it would be, but got delayed. Anyways, so another thing you can do is you can annotate the plot. So here, for example, this button adds a data relative arrow. And so what I mean by data relative arrow is you could create an arrow and point it to a signal on the window. And if you wanted to highlight, say, this dip right here, and then if you scroll in time, that the arrow moves with it. So if you wanted to highlight some point in the data, you could draw this little arrow here and tie it to the data, and then you can also create some text. So you can create a little text box, and put some text in there, and then that text also would stay with the data. So you could, if you wanted to mark up a file with some annotation and share it with some colleagues, you can put some things in there, and you don't have to make a lot of you can still zoom in and out while you're analyzing without messing up your annotation. And these are saved with the config file. So when you put some time in setting up all your plots, you can save them to a configuration file that you can then load again later. And these arrows and names, they're saved with the configuration file. They're not saved with the data file itself. And so another feature is the undo and redo changes. So like if you click on this zoom by rectangle and you zoom into some area, and then you're like, oh, I don't want to do that, you can click on this back button to go to your previous zoom level. And looks like that's affects the text there. But yeah, so this is kind of like undo and redo, you know, previous items. And then there's also zoom full page. So if you click on this, it'll automatically zoom the time and y-axis to cover all the data, similar to like when you initially plot signals. So, and then you can undo that change if you want to and go back to where you were. So, you know, all of these features are, you know, they've got a little floating text to say what they are. This one here turns on the individual data points. So sometimes if you're looking at, you know, really details of the data, you want to see exactly when did records come in for each signal. So I'm zoomed way in here now. I'm only looking at 3/4 of a second worth of data. And if I click on engine speed, for example, then I hit the arrow key to move my cursor. With each hit of the cursor, my cursor is moving from record to record on engine speed. So if you really want to look at the data from record to record, you know, you can select a signal in the legend, and then you can use the arrow keys to see exactly what's going on, you know, with a particular signal. We also have this table at the bottom, which shows you the numerical values of all the signals that are in the current window. You know, in case you wanted to just see a tabular view of all the data that's there. You'll notice that, especially with CAN data, there's a lot of different time vectors. Like the data doesn't come in at all the same points in time. You know, even among these three signals that I have in the bottom graph, I think, yeah, outputs, yeah, they're three different time vectors. So like output speed is on one time vector, and you can see by the individual points. And turbine speed is a different time vector. It appears to be the same rate as engine speed, but it's not lined up exactly. So, but when you place the cursor somewhere on the screen, the legend shows you the value at the cursor. And, you know, in general, your cursor is not on any exact points on the plot. So what's shown in the legend is the value that most recently precedes the cursor. So if my cursor 1 is here, it'll report the value of the first data point that's to the left of the cursor. That's how it works. It doesn't interpolate or extrapolate or anything. So so then there's this search feature here that you can use with this icon that has the binoculars. And then there's a quick search and there's an advanced search. And the advanced search, you can look through the current directory for some event. So you could say down here at the bottom, you can type in a string like engine speed, and then you double click on it and it puts it in the expression. And you could say engine speed greater than 4,500, for example. And then I pick the current directory, and then I click on find all, and then it'll search through all of the files that are in the current directory that the file that I opened is in. And it will show you all the places where my search expression was found. And at the top, it tells you what the expression was. So up here, engine speed greater than 4,500. So you can just click on, you know, one of these hits, and it'll take you to wherever the speed went above 4,500. So if you look at my cursors here, cursor 1 is right when engine speed went above 4,500, and cursor 2 is right where it dropped below 4,500. So it puts the cursors on the bookends of your expression, and this is even across multiple files, you know. So so you know, here I think I have like, I don't know, 60 files in my you know, in this setup. And so if I click on, you know, any one of these, it'll load that, whatever file I click on, it'll load that in the list and take you right there. So you can use the arrow keys to step through all the hits. Here's where the engine speed just barely hit 4,500. So you can do searches through your data. And we have some other ways of doing more advanced searching, which I'll show you in a minute. And okay, so yeah, you can load the configuration, and then at the end there's like a help icon, which tells you when your upgrade date expires. This is only for the PC version, with although there is, some, if we add new content to DataSpy, we will include it in the vSpy install. So as newer versions of vSpy are released, they will in general have more content added to DataSpy. And so this help tells you the version number that you're running right now in DataSpy, and when your license eligibility runs. And this works whether you're using the cloud-based version of DataSpy or the PC version. So it's still helpful for the neoVI, the cloud-based as well. So okay, so one other thing I'll show is there's a number of different types of graphs. So here I'll close this. Remove selected graph, and then I'll add the XY graph. This is something that we've recently added to DataSpy. And so here you can plot, output speed. And this is a plot that does not have time on the x-axis. So you can drag a signal and drop it on the x-axis, and it'll put output speed on the x-axis. And then you can drag turbine speed onto the y-axis, and then it plots turbine speed versus output speed. And but it only plots the data that is in the current window, And so as I zoom out, it shows me all of the data, trans output speed versus turbine speed versus output speed. And so if you're a transmission person like Kevin Kawakami, who I saw in the attendee list, this data, the data of constant lines here represents when you're in a given gear. So the slopes of these different lines represents the gear ratios for trans output speed. For the transmission. So let's just see if there's any. Okay, so I'm gonna just remove that for now. Okay, so that's pretty much the basic plotting features of DataSpy. I didn't show you the multiple pages. You can overlay files, so you can add an overlay file, and then you can time offset the overlay file, so you could line up events. I wasn't planning on reviewing that today. Let me just take a look at my notes. Yeah, so the next thing is consecutive files. This is a really cool feature that we recently added to DataSpy, and we call it auto open consecutive files. And so let's set the start time to say 1,000 seconds. And so now if I'm looking at the first 1,000 seconds of my first file, and if I put my mouse on the time axis and I scroll out, once it gets to the end of my the current file that I have open, it'll look in the folder that the current file is in. It'll look to see if there's another file in the same folder that is from the same collection as the file that I opened. And if it finds it, it will automatically open it, and it'll just extend the plot. It'll extend all the plotted signals that you've made to go to that next file. And it puts this orange border between the two files that you can hover over. And this border tells you the name of the previous file and the name of the next file on either side of the orange border, and also the time gap between these two files. So if you have a whole bunch of data, like say you drive for the weekend, you got all your data on your PC, and you just want to scroll through all the data, you can just turn on the consecutive files feature, and then analyze all of your data. Yeah, in this case, I think I didn't open the first file in the list. So once it gets to the latest file, then the plotting's over. And it shows you in the time axis, where you're at in time in seconds relative to the file that you had opened. And what we call the file that you opened, we call it the basis file. And let me just replace the active file. So if I click on replace active file, what that does is it allows me to pick another file without changing my config. So I just picked a new file to use as my basis file, and I picked the oldest file in the list. Because it's a little better to show you the consecutive files feature. So there's no files older than the one I opened now. So as I scroll out, it just opens up a bunch of files, and and the time always shows you how many seconds since the start of the first file that I opened. And so here, if you look, there's these two files that have like these thicker borders than the others. The orange line is thicker on these couple of files. And the reason it's thicker is if there's less than a second worth of time between the two files, it puts a thinner border line there. If the delta is more than a second, it puts a thicker border. And so here you can see the time gap between these two files. Excuse me, the time gap is 5,300 seconds. And but it puts a discontinuity in time because nobody wants to see a big hole in their data. But they want to know when the time is shifted. And so so you could easily look through all your files from your weekend drive without having to jump or hunt around in time. And so it also shows you the absolute time in blue. Like if you see down here, the blue time in the time axis shows me the date and time of day, wherever my cursor is, in the file. So some people, they'll want to see, hey, what's the date and time of day where this data occurred. But if you're really trying to dig into some complicated interaction with signals, the more common, interest is just the relative time in seconds. So that's kind of, how that works. So, yeah, that's the consecutive files feature, and that also works on the cloud versions of DataSpy. And okay, so, and I think we'll make this PowerPoint available as a PDF to everyone. They can look at, and they can send me an email, give me a phone call, and ask me any questions that you want. I'd be glad to, to spend more time talking about it. Okay, so next thing I want to do real quick, and we're already only have 12 minutes left. So I want to show you the GPS view. So here's a file that has some GPS data in it. And so I'll plot engine speed there. And so you can click on the GPS view, and this file also has latitude and longitude in it. And latitude and longitude in this file was recorded using our tools. So the Ion, the Red 2, and the Fire 3, they all record. They all have built-in GPS. There's some other products too that have them. And if you enable it, they'll record the GPS coordinates, along with the vehicle network data. And so, and we support 3 different maps in the GPS view. We support OpenStreetMaps, Google Maps, and Baidu Maps. And I like Google Maps the most, but Google started charging on a per-click basis. So it's kind of a long story. It's not that expensive. You can make your own key, and it really doesn't cost you anything. It's only if you're a big company. but it affects our use of Google in a product that we sell. So that's why we added OpenStreetMaps. But as you can see here, you can click and drag on the cursors in the time in the plot window above, and it'll move the cursor here in the map view. You can also click on the cursor in the map view, and it'll move the cursor, up above. And we have some customers that they log a lot of data on their proving grounds, and so they want to be able to see, hey, where am I during this particular point of data? Am I climbing a hill or on the grounds or whatever? So it's kind of a cool way of doing that. And by default, it looks for the longitude and latitude signals that are standard with our tools. But if you have, like, say, a CAN signal that has latitude and longitude, and you want to switch to a different signal to use, you can choose your signal to use here. You can pick any signal you want to use as latitude and longitude. It requires that it be in decimal latitude and longitude, but you can also use calculated signals as well. So anyways, that's the GPS view. And the next thing I wanted to show real quick is the video graph. Yeah, so here is the video graph. Let's see. Looks like it didn't. Some issue there. Maybe it's confused with the other files I had open. Okay. Yeah, so it's when you open a data file, it looks to see if you log data with camera data with our tools, it puts the let's see. Sorry. If you record video data with our tools, it puts all the video in a separate folder called video, and it has like a JPEG for every frame, And so when you open a file in DataSpy, it looks to see if there's a folder called video, and if there is, it'll pull up the camera data, into the channels list. And so so here I'm gonna add a couple of these plots. The number of people at camera 0, number of people in camera 1. I'll add those two counters, and then I'm going to add a video graph here. Add video graph, and then you can plot the camera data on the video graph. So I got 4 camera channels. I drag and drop them on the video graph, and it creates this it shows these tick marks here, and just gonna make this a little bit smaller so you can see all 4. So it shows you the 4 channels down here in the bottom, and these little tick marks show you in time, where are the individual frames of the camera data. So if I click on camera 0 and I hit the arrow key, this is camera 0 on the left, and you can see it goes frame by frame on camera 0. And I can click the right arrow and it moves it forward and backward. And the borders around these camera windows, they match up with the colors here. So the red is this one, the magenta is this one. So you can kind of easily see, all 4 camera channels. And, in this data, we had an intern that we had him use some machine learning to process video files to count how many people there are in the video. I'm just going to make this larger to show you just the two main cameras. So, and she also calculated how many people there are in each camera. So this green signal is how many people are there in camera 0. So this is camera 0, and you can see right here it blips to 1 person briefly. And this video is a processed version of the first video. So right there you can see that the machine learning identified a person right there, but it's right on the edge of identifying it. So that's why it's blipping between 0 and 1. But once I get to here, then it's 1 and it stays 1, and that's when someone walks right in front of the vehicle. And so as I scroll through, it shows her this woman walking in front of the car, and it shows how the machine learning identified there being a person there. And then if you zoom out more, here is where there's 2 people that entered the frame, right there. That's myself and this woman that was working for us at the time. And so the whole idea here is you could process the video to say, hey, I want to find when the number of people in the picture went from 0 to non-zero. So you could see how the car reacted to somebody being in the frame, or the number of stoplights went from 0 to non-zero, or the number of other cars, so you could use the search tools to find, video events of interest, but and this, you can float this window to put it on a separate screen. So if you have multiple monitors, you can have all the camera data shown on a different monitor. And so that's the video graph feature. And yeah, then I want to just do a quick review of some stuff here. Like we have this data mining framework that's built into DataSpy that we call integrated post-analysis. That's the name of this library. And we've packaged the file IO library into this DLL and shared object library, so you could write scripts to use the file IO features to mine through data. And you can run the data mining on your PC, or you can run it on the cloud server. So you can set up elaborate searches or data mining activities and develop them on your PC, and then you can upload them to the cloud server and have the cloud server run them on terabytes of data. That's kind of the idea behind that. And this is an example of the output of one of those scripts that we call find in files. And so it was set up to search for a bunch of different events in a bunch of different files. And so I'll look at 30 seconds worth of data, and it shows you all these events at the bottom. So, and you can name the events that you're searching for. So this is this engine state variable changing from 9 to 10. And so here's the engine state variable, and here's where it changes from 9 to 10, so, and then there's a watt launch from rest. You can click on the watt launch from rest. And if you look at pedal here, this is where the pedal goes to watt. And so there's all these different events like tip out upshifts, for example, and you can just click on the events in this window at the bottom, and it'll take you right to the event, and you can sort by them as well. So you click on the header, it'll sort by the event. So here you can step through all of the engine state variable changes from 9 to 10. You could use your arrow keys, or you can click on the data. So the idea here is you could pre-process the data as it comes in to the cloud server and identify events of interest. And maybe you're in charge of, tip out upshifts, so you could just jump right to all the tip out upshifts, in among the data. You don't have to spend a lot of time searching for the data. So this is, IPA, the data mining part that allows you to search for events. That's included in IPA, but you can still analyze data on the cloud, even if just looking at YT plots on the cloud. And this, what I'm looking at right now, is just a browser. It's a browser, a Chrome tab, and so you don't have to install anything to use this. You can just access the browser from your living room PC, or a tablet, or anywhere you want, and you can see an event of interest, and you can copy a link to that event to the clipboard, and then you can IM that link to a colleague. And if your colleague has an account on the server, they just click on the link and it takes them right to the same data that you were looking at. So this is not a screenshot. This is the actual data that you were analyzing, and then they could say, hey, I saw this little blip in a shift that didn't finish. Well, then you can look at the data and add some, more signals and say, oh, I think I understand what caused that. And then you can send back the link, to your colleague. And so you can correspond with each other without having to send, large data files. You just send these links back and forth, and the links are, really small. So it's one of the great features of DataSpy. So it looks like we're out of time here. Kind of didn't plan my time too well. But we'll share this PowerPoint with you all, and if you want to look it over, and if you want a beta installer, we can send you the beta installer for DataSpy. That's included with the vSpy, and which, oh yeah, that was the one thing I meant to do as well. So like, here's vSpy. So I just opened a VS3 zip in vSpy, and if I click on File, Review Buffer, I can choose a file. Click here. Presentations. And I think there's a survey you can fill out.
Yeah, I was just going to say, before we finish up, I wanted to give an opportunity for anyone to send in some questions before we finish. And then I also just submitted a poll for you guys to follow up on. I also sent the Intrepid link tree, which has the links to all of our social media where we'll be posting this video and the presentation slides. And then I also put in the chat John's LinkedIn link, so you guys can add him if you have any questions for him directly.
Yeah, thanks, Jordan.
No problem.
Yeah, so I just loaded a data file into the review buffer of Vehicle Spy, and you can see it has some signals decoded here. And if I click on this DataSpy button, it'll generate an MDF file from the data that's in review buffer, and it will open DataSpy with that MDF file. So then you can start plotting data, right away. And this particular data has a GPS in it as well. So here you could see, I'll click Google and zoom to route. And this is like me leaving our complex here on Research Drive. And then if you go back to the review buffer, back to vSpy, and you pick a different file in review buffer, like say this one. And once it's done loading that new file, you can click on this DataSpy button, and it'll automatically load that new file into that version of DataSpy. And it's separate from the PC version, which if you're using the one that's in vSpy, you're probably not using the standalone DataSpy, but you can see that from the GPS, this is later in my drive, a later data set. So anyways, thank you all for attending, and I hope to hear from you with feature requests and whatnot from DataSpy, and we'll send you out a beta as well for vSpy that has it included already.
Perfect. Thanks, everyone.
So there's a new, okay, cool. Okay, thank you. Bye-bye.